So the first thing we do is when we start out our survey is we would look at the chart with the positions of the standard sampling locations, and we decide based on which ones we're going to do first. If it looks like it's going to be windy and narrow waters later in the day, we may want to do those earlier, and we're always thinking about how we're going to get back later in the day if the weather blows up. So we've decided which station we're going to go to. We go to the GPS position for the station, and we position the boat with the winch on the windward side so that as we move with the wind, the wire will lead away from the boat and we're less likely to catch anything because we have an expensive piece of instrumentation that goes on the end of the wire and we don't want to damage it or lose it. So what we do when we get on station, we're going to be filling out a log. We have a daily cruise information, which is basically the information on the vessel, the date, what instrumentation we're using, serial numbers and such. It's a trail breadcrumbs for processing, and fill in the group. And the notes at the bottom, I always encourage people to put anything interesting in there, weather, anything that they thought may not be working correctly. They see fish jumping, anything like that. If it looks like a fishy day, it's always a good thing to put that in. For each of the stations, we fill out another page, which is the station information. And this is again date, station name, latitude, longitude, GPS event. And so we put in a start and an end on it so that if you do drift a lot, if the data shows a lot of smearing in the profile, we can say, well, they drifted half a mile or something. That's too much. Maybe we want to have a word with them later about that. We always put the start time in because the instrumentation is recording time with the different parameters, and so it's easier for processing if we know when it started. We're using a hand winch this time, which has a counter on it, so it's not counting meters, it's actually revolutions. So we always put the counter at the bottom so we know where the bottom is. So when we do a cast, we'll crank it down to the bottom, we'll find the bottom, and then the second cast again we know where the bottom is so we can stop nicely without running into it. Water depth from sounder, whether we're doing water samples, nutrient samples, whether we're doing zooplankton. And when doing zooplankton, you have to put in what you think the maximum depth was and the wire angle. And the zooplankton that has a flow meter on it. And again, any notes, if something happens in the middle of the cast and the wire comes off the winch, then you have to put that in, saying first cast, we stopped halfway through. So when someone processing it looks at it, knows what happened, or if there's anything different. And again, if you see something like someone says, well, look, the tide's running, we're right at maximum flow. Let's put that in, because that again is useful information. It's easier to get it here than for someone to look later and compare it with the tidal records. It's a good indication right away that you've got that. So what we'll do is we'll clip the instrument on. We'll put the bottom weight on it, which we use to find the bottom. So the bottom weight hits the bottom, not the instrument. There's 5 meters between them. And usually with a small winch like this, you can feel when that weight hits the bottom. You can feel the weight come off the winch. And that's something to remember, that when you're drifting quickly, you're less likely to feel it if you're going slowly, because the boat is going to start dragging it and you're just going to feel the drag. So we'll put it together. Okay, so let's get CTD out. So this guy is our RBR Concerto CTD. It's got temperature, conductivity, which is salinity, and pressure sensors on it. It also has a fluorometer here, and it uses a light, shines on the phytoplankton and gets a different frequency light back, an excitation frequency. And then we also have an andro-optode over here, which is an oxygen sensor. These two sensors are both optical sensors, so the active part of them will bleach with sunlight. So normally what we do during the day is we'll keep it in the box so it's out of direct sunlight, and at the end of the day we'll put the rubber caps on. This guy likes to be a little bit wet, so we put a little bit of water inside here and we close it up. Okay, this is basically just a scratch cap. There's two little windows there. We don't want to have this surface scratched. So at the end of the day, again, we'll put this back on. But in between casts, we can usually get away with just keeping these here. And that usually keeps things simple. If not, we tend to lose caps. Okay, this guy on the bottom is a 5-meter bottom line. And we put a weight on the bottom of this. So when it gets lowered to the bottom, the weight hits the bottom, not the CTD. And then we know where the bottom is. We can feel it with the winch. You can see it either with a mechanical winch. You can see the line go slack slightly, or you can feel it with the hand crank winch. You can feel the tension come off. Okay.
Okay.
So
now what you're gonna
now we're going to put it
Keep it on.
put it on the line. So we put the weight on. Okay. So this guy here. One Navy approved knot. Okay. And let's put this guy down back here. For small boat operations, what we've used for simplicity is a modified Scotty downrigger. The modifications are that we put a disc in the middle here, so we've made the drum wider so we can put more wire on it. And we've also put a wire which is much thicker so it doesn't get kinked. So this is basically a standard downrigger like people use for salmon fishing. This piece of tubing here will be used for mounting the water sampling bottle on it. The winch has a brake just pulled toward you to come off, and it's a safety, so it has to be held while it's going down. Okay, so it doesn't free fall and just keep going everywhere. So once I pull tension off and I let go of it, it stops. Okay. It has an extendable handle on it so that you can get a little more purchase on it. This gets clipped onto the top of the CTD, and you always clip it on inboard. Okay, nothing goes over the side of the boat until you're sure it's secure. Okay, so there's an arrow on the end cap. There is an off and an on position on the body to turn on, turn clockwise to on, and the body will shake. There's a little shaker in it so you can feel it buzz, and that will tell you it comes on. Once we've got this on, then we'll put the weight in the water, and the idea is you make sure everything's really safe. So you don't want anything to jerk over the side nastily. So you take the weight on there, and the weight, okay, and so we leave that in the water for at least 30 seconds at the surface, and just give it a chance to start its record, everything sort of calm down. And also, if you have a big disparity in temperature, if it's been stored at 25-30 degrees in a car and the water's only 15 degrees, it needs to cool down to 15 degrees. So we give it some time to cool off in the water. The temperature sensor itself is very small. It changes temperature very quickly. The body of the CTD will actually contain some heat. So if there's a big disparity in temperature, then you have to make sure that you cool down the body of the CTD, because it will have a self-heating effect on the temperature sensor. So we leave it there, we make sure everything's happy. Okay. So this counter on here is in feet. We work in meters. Take the brake off and start going. And this measures on the way down. We want to go down about a meter a second. So 2 turns every second. 1 and 2 there. So we started at 976, so I'm expecting something around about 200. I'm going to feel the weight come off this. We've got a little bit of wire angle. It's leading away from the boat because we're drifting. So that means the counter is going to be deeper than what the actual depth is, because we're going on a slope. And that's what's known as wire angle. Okay, stop there. Okay, so I felt it hit the bottom. Wait a couple of seconds, just make a mark. Okay, and then we bring it back up again. Make sure that the wire goes on neatly onto the winch drum. And coming up, it can come up as fast as you like. So when you're bringing it up, you're going to have somebody looking for it. As soon as they see it, they yell sight. Then everybody knows, so nobody's falling asleep. Okay. There. And you bring it up just below the surface. Okay, we normally do 2 casts. Okay, so you wait 30 seconds there, make sure that it's equilibrated to the surface temperature, and then you go back down again. So we're going to do some water sampling. This is what's known as a Niskin bottle. It's a standard oceanographic sampling bottle. It has 2 ends which go down open, and then we trigger it with a weight on the line, and it closes the bottle, it captures the sample. We have an air vent screw at the top and a spigot at the bottom for taking our sample out. Okay, so to prepare this bottle, we have to cock it. So basically, open the top, pull the lanyard through the handle, and it goes into the clip like that. There are 2 clips on this one. You see that there are 2 metal posts here. One of them moves on the slider, and the other one moves with the rod and the piston on it. Okay. To do the bottom has a small brass boat clip on it. It clips around the 2 pieces of monofilament in the loop, and it goes on the end, so it's outside of the ball. If it goes on this side of the ball, it can't slide off. If it goes in the loop over one of them, it can't come off. It goes around both of them, and it goes on the outside. Okay, so before we put our bottle on the wire, we make sure that the air vent screw is finger tight. It doesn't have to be super tight, it just has to be tight. It's got an O-ring on it. And we make sure that our spigot is pulled out and it's rotated away so that the alignment hole is away from the post. Now it can't open. That's in the closed position there. There's a bolt here with a notch in it. That notch is going to go around the wire and around the surgical tubing. We put surgical tubing on here so that we don't crimp the wire itself, and that way we don't weaken the wire. So we're basically just squeezing the tubing onto the wire and it makes it stick. One. Okay. Just like that. So basically we're gripping the wire inside the surgical tubing sleeve, and it doesn't have to be super tight. It has to be tight enough that you squish the tubing and the tubing is gripping onto the wire, and it shouldn't slip. This isn't going to fall off the wire because it's right against the bumper here. We leave the CTD on because the CTD is still running. It measures depth. So when we put this down in the water, we know exactly how deep the water sample was taken from. So we're using the counter or a mark on the wire as a general indication of how deep it is, but we also have a record on the CTD telling us exactly where it was when we closed it. And if it's a rough day or we're drifting and the wire's on an angle, the mark on the wire and the counter won't be accurate. This will be the exact mark. Okay? So now what we'll do is, again, we put this down to the surface, and it says 978, so we're going to go down to 20. So we're going to go down to 40 on the counter. Okay? So it's going to be 40 down, so it's going to be 16. Okay, brakes on, so I'll stop there. Oh, got one. This is what's known as a messenger. It's just a big block of brass. It has a little clip on it. Basically it clips around the wire. The clip holds it on. The lanyard here is just to pick it up. Okay, so what we'll do is slip it around the wire, Okay, hold above the wire with your finger and let it go. Drops at about 1 meter a second. It's going to hit the thing and there's going to be a thunk. And you can feel it on the wire. You saw this actually moved as well. Okay. Break off. Crank it back in again. Okay. There we go. Yep. Put this guy up.
Take it off?
Yep. And there's a handle you can grab, so when it's sloppy you want to make sure that you're supporting it as much as you can so you don't drop it in the water. And if people aren't comfortable with, depending on the boat or how much it's rocking, bring it all inside. Water sample, now we want to put it into a sample bottle. So each boat has a cooler. The cooler will have a couple of cooler packs, and it will have plastic bottles for putting samples on with labels determining where the sample was taken. So this one was from the boat Elvis, our station number, date. We have an A and a B sample because we do replicates, and at the bottom it says what depth they were taken at. Okay. When we do nutrient samples, we wear gloves. Okay, and there will be gloves provided in the kit. The gloves, if you end up getting extra gloves later, they should be gloves that are dust-free, so they have no talcum powder on them. That tends to spoil the sample a little bit. Okay, so we'll do our A bottle first. Okay, so what we do is we check to make sure that the bottle actually sealed properly. So the first thing we do is we open the stopcock at the top. Okay, and no water should be dripping out of the seal or out of the stopcock here. Okay, we do that tight. That guy, no water should be coming out. That means this seal is good. Okay, so pull it back out. Open that. Line up the pin with the hole. Put a little bit of water into it. Wash it around. Wash the cap. Okay, rinse the cap out twice, 3 times. Last time we do it, fill it about 2/3, 3/4 full. These are going to be no higher than 40. Do that. Okay, so there's room for expansion when these freeze. Cap goes on tight. Goes in the cooler. Look for the second one, confirm the label's correct. Same thing. Rinse. Rinse the cap. Rinse the cap. Rinse the cap. And the 4th time, fill. And if you fill it too much, then just flick. Okay, get down to about 40. Okay, it's sampled in excess, so it doesn't have to be exactly 40, but you don't want to put too much in here, so when it freezes, it pops the top off. So it has to have at least 10% headroom in the top. Okay, and these go in here, they'll be cooled, and then they'll be analyzed later. Okay. The samples go back into the tube holder, the rack. They're taken ashore cool in the cooler. If they're going to be sampled or analyzed within the next day, they can be kept cool. If they're going to go over more than a day or so, then they should basically be frozen. And these samples will be frozen, and then they'll be shipped frozen to where they're going to be analyzed. So They should be kept together for the day, so that if you do have to keep multiple samples for more than one day out in the water, we can keep them into sort of discrete groups. It makes it easier to analyze and makes it less easy to make mistakes.
So when we're done taking the sample and we're done with all the water in there, let's dump it out.
Okay, and then it goes back into the tote so it doesn't bang around when you're in transit. And it's a good thing to remember, if you can keep all your stuff in a box or at least secure, then if it's a rough day and things are banging around, or if there's a fuel spill on your boat or fish scales or anything like that, we can keep our stuff clean and keep it from being broken in transit when you're in the boat. So tidiness here is a good thing, because then you know where everything is, everything's secure, nothing gets broken, stays clean, and also you can make it a routine so that you know exactly where to pick things out, and it goes much faster that way. Okay, so when you're finished doing your water sampling, grab the CTD, pull it up, bring it inside the boat. Okay. Once it's inside the boat, you can unclip it, turn it off. Okay, it should vibrate again. Then you can put it back in the box. It doesn't need to have the dust caps put onto the sensors unless you're finished for the day, or you can't keep it someplace out of the direct sunlight. So we'll put it in a box and we'll put the lid back on it. I generally put a little bit of line on the end of the ball just so you got something to go onto, because some of these get pushed in. Okay, and then put your ball someplace secure where it's not going to break the instrumentation. I like to keep them in a different box to what the instrumentation goes in, because this is a small wrecking ball. If you have a Scotty ball holder, those are the best things. If not, put it someplace where it's not going to roll around and break things. Secure your winch, so bring it in so it's tight. Put the brake on, and that way none of the wire can fall off the winch, and it keeps it nice and neat. It's ready to go for the next cast. When you're done, put the lid on the box here. Okay, and keep that out of the way. Make sure that your lid doesn't blow away when you're running. We also take a sample for phytoplankton analysis. We're looking for presence of harmful algae. We use a small glass bottle. It will have a label on it, and this sample is taken from the surface. The sample can be taken by hand, just under the surface. Rinse it once just to make sure there's nothing in the bottle. Get the bubbles out of it. Bring it up. A little bit of room for expansion. For identification of the phytoplankton, we use a stain called Lugol's iodine. It's basically a over-the-counter drugstore product. It's relatively non-toxic. We put a couple of drops in here. What we want to do is put enough in here so that the water turns a light tea color. That's probably good. 2 drops. Okay, and generally if you put too much in here, you should put it back. So, no contamination. Put the lid on snug. There you go. It's dark enough. Okay, and then this goes back to the lab for analysis for harmful algae. This is an old-fashioned way of measuring how much light is going into the seawater. It's called a Secchi Disk. We lower it into the water until we can't see the white pattern on it, and then we measure the depth that we can't see that, and that's known as the Secchi depth. What this tells us is a couple things. It tells us, one, how much material is in the water, either sediment from a river, runoff, or it could be turbidity caused by phytoplankton, or it could just be stuff being stirred up in the water column and making it hard to see. This tells us 2 things. It tells us how much material is in the water, so whether it's river sediment or whether it's phytoplankton. And it also gives us an idea how far the light is penetrating that will be used, the phytoplankton uses to grow. And so it tells us how much production is in the seawater that will ultimately sort of lead to what the fish are eating. Okay, so this guy has a line going through it. The line has marks on it, tells us how deep we put it, has a loop on the bottom. Take the weight that you use for clipping on the bottom of the CTD, put that on the bottom. Okay. Lower it into the water, and we lower it until we can just not see it. We're looking for the white, and there it goes. Okay, so it's just gone. We pull it up a little bit and just see that. Okay, so you grab the mark closest to the water. It's a black mark, so that's a ½ meter. So it's a ½ meter to the yellow, half, 1, 1.5, 2, 2.5, 3, 3.5, and that's about 4 meters. Okay, it's pretty subjective, so we'll do it again just in case. Do it until it disappears. Bring it up until we see it. And it's just about there. So it's that black mark. So half, 1, 1.5, 2, 2.5, 3, 3.5, 4 meters. And you put both measurements down in your log. So you fill out the log for each station in the station information form. When the CTD cast starts, it says local time. Okay, so that will be either local daylight or local standard time, but it will be whatever local time it is on that day. The counter at the bottom, we had 336. Second one was at 1412. And the counter at the bottom was a little deeper, 338. The sounder was 110 meters. Nutrient samples, we did duplicates at 2 meters and 20 meters. And vertical net tow, we didn't do a vertical net tow. And then we'll say we were drifting to the west, to the southwest. Okay. And so normally every field here should be filled in, unless you answer no to something. So there should be something on every line, and the notes, if there's anything different that happened that cast, put it there. And there's also room on the other white side of the page to do something. So if you see fish speeding in the area, that's always a good one. Or if you see marine mammals feeding, or herring balls or anything like that, put that in as well. Okay. And at the end, we do the GPS event, so we know that we started at this point and we ended at that point. So this is where in the notes, if you did a Secchi depth, you can put that in. So you put the depth in. The first one was 4 meters, and the second time was 4 meters as well. So that's in there. And we'll say that there appears to be something green in the water. Okay, so if you see that your observations say that it was greener one station than another, or if there was mud in the water or whatever, put that in, because that's all part of the observation. Okay, and then you're ready to do the next one. pin comes out, and then the pin stays with the winch.
Okay, thanks.
So at the end of the day, you want to rinse down all the equipment that's been exposed to salt water with freshwater hose on the beach. We do this for two reasons. One is for corrosion, and the other is just to get all the biological stuff off it so it doesn't smell. So we're going to rinse down everything that's been in the water, and that includes our downrigger winch, and we want to rinse down the wire. Okay, so the winch is done. So the oxygen sensor has a cap on it. The cap should be moist. There's this window here, that's the actual sensor part of it that measures the oxygen concentration. This little nubby here is a temperature sensor, it's temperature compensated. Okay, make sure that the cap is wet when you put it back on. The membrane likes to be a little bit wet. Okay. The fluorometer has a dust cap on it. And you want to make sure that the face of the sensor is clean, and you try not to scratch it, and this cap just goes on to keep it from being bleached by sunlight, so you don't want to bleach it in broad daylight. All the cables, you want to make sure that they look like they haven't had any damage to them, that they're attached to the CTD, that the curves, nice lazy bends in them, and that they're not chafing on any of the hose clamps or anything else. Watch the end of the hose clamp there, that it doesn't catch on anything. This guy here is the conductivity sensor, measures the salinity of the seawater. This is the thermistor that measures the temperature. The skinny little needle is the actual sensor. It's very quick. This is the port for the pressure sensor. It should be clean and should be able to drip water out of it. And if you're ever, you should always shake it out a little bit and make sure that the water comes out. Make sure your bottom line is all tied up so it doesn't catch on anything. And it's all ready to go for the next time. Okay. I'll put this guy in here.